Hey, this is Coach Latham, and this is part two of the Geometry SOL review. We're going to start with talking about congruent triangles. Make sure you always look at what's given, and remember the order of the letters in the given statement is the most important thing when matching things up. This one asks for the value of x. X is right here on QR. QR is the last two letters. BC is the last two letters. Therefore, it's going to be 3. Matching things up in a similar manner, you've got a few problems here to work on. Scroll through and hit pause as you need. Remember, they asked for the perimeter in this one. This one's an interesting one. You're given that these two base angles are the same, therefore you know both the legs are the same, or both the sides here. That helps you find the perimeter. This one I made up. It just reviews the different properties and theorems you can use to prove triangles congruent. The ones that are highlighted are the ones that are used, although on the SOL test, they usually tell you which one you're going to use. That's an example of angle, side, angle. The 12 needs to match the x because it goes angle, side, angle, angle, side, angle. This one tells you it's side, 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 so we need all three sides to match up. The missing piece of information is right here. This one tells you to use angle, side, angle. Remember to read the directions, otherwise you may get a correct wrong answer. And then we'll move into similar triangles. Remember, similar triangles aren't exact matches. They're different sizes, but they are the same shape. So the angle is one that you'll use quite a bit. And then the others will work if they're in proportion for these two. Side doesn't prove anything by itself in terms of similarity. Most of the examples don't involve you knowing those different postulates and theorems. You're simply going to match things up and set up a proportion. Proportions can be done in more than one way. You just need to make sure that whatever triangle you start with, that you match up the corresponding parts and you stick with that one as your first triangle. For example, in this one, if you were to set up x to 6 as your first fraction, you would put x over 6. Then you're going to have to start with the same triangle that x is in when you set up the second half of your proportion. So it would be 15 over 10. There are other options and other problems. You could have gone backwards, or completely opposite. Just make sure that whichever triangle you start with, you stick with that as your start for the second fraction. Here are some more for you to try. Hit pause as you need. This one asks for the perimeter. This one asks for the value of x that would prove these things similar. This one is going to end up being an angle, angle, angle. Make sure you match up corresponding parts. And then we go into right triangle trig. Well, the easiest ones are the things that involve the Pythagorean theorem. Whenever you know the two short sides of the triangle, it's just a matter of squaring them, adding them together, and then taking the square root. If you were going to try and set this one up on your calculator all in one step, it would be the square root of 12 squared plus 16 squared. You could just type it into your calculator like this and hit enter, and that would give you the answer. When you're given the hypotenuse and one of the shorter sides, like in this case, you're given the 13 and the 5, and you have to find the other short side, you can set this one up in your calculator in a similar fashion, but it's 13 squared minus 5 squared, because remember, the two short sides add up to get you to 13 squared. So you could type this one into your calculator to get the answer for x, and do this one on your own. Make sure you type it in correctly. This is an interesting problem, and we talked about this a little bit in part 1. A, B, C, and D represent 4 possibilities for triangles. One of them is not a triangle. One of them flunks the triangle inequality question, which is where you subtract the first 2 numbers and add the first 2 numbers, and the third one doesn't fit in between. After you eliminate that one, run the Pythagorean theorem on the other 3 to see which one has the longest side that's too long to be the hypotenuse, the longest side that's too short to be the hypotenuse, and the longest side that's just right to be the hypotenuse. And here's how they match up. This is just a slide to remember the trig functions. You'll need to know these for the test. It's not on the formula sheet. And here's an example of a basic trig problem. It's asking for which fraction represents the sine of theta. Remembering that sine is opposite over hypotenuse, it would be 9 over 15. Here are some more for you to try. And here's the type of problem that you'll see most often on the test and really in life, in practical applications. You've got an angle here. We only have one side of the right triangle given to us, and so we're going to have to use trig. Well, the x is opposite the 44-degree angle, and the 10 is the hypotenuse. The trig function that uses opposite and hypotenuse is sine, so we would say that the sine of 44 is equal to opposite over hypotenuse. Now you're almost ready to use your calculator, but you got to do a little algebra here to get x by itself. You could multiply both sides by 10. That cancels out over here, and you get a 10 right here. And so 10 sine of 44 is equal to x. You just type that into your calculator, and you get something real close to 6.9. Here are some other ones to try. This being the most difficult one because you end up with the x on the bottom of the fraction. Those are the ones that are difficult. This one, we've got an opposite and hypotenuse, so that's another sine problem. So the sine of 44 is equal to 10 over x. You got to get the x out of the bottom. So that's going to end up being x sine 44 is equal to 10. And then to finish getting x by itself, you're going to divide both sides by sine 44. So it's going to be 10 over sine 44. And type this into your calculator, and you'll get the answer. Quadrilaterals and other polygons, you've got a couple special relationships that you're going to need to know here. Again, we've already talked about how any four-sided polygon is going to have 360 degrees, so this one just ends up being subtracting from 360. Now, when you get a parallelogram, that's a special quadrilateral that we talk about. These opposite angles here, they look like they're the same, and they are. It's the opposite angles in a parallelogram are going to be the same, and consecutive angles in a parallelogram, since they turn all the way around, are going to be supplementary. So if you know one angle in a parallelogram, you automatically know all the others. You can try and answer these questions. Going the wrong way. This is an interesting one because this is a transversal. So if this is x, then this one up here is going to be x. And if this one's 30, this one down here is 30. This is just the Pythagorean theorem here. Remember, if we're going to use our calculator to make this one easy, 50 is the hypotenuse, so it's going to be the square root of 50 squared minus 30 squared, and that'll give us our answer. An isosceles trapezoid, right here, it's got base angles that are the same, so if this one's 80, this one's 80. And since the top and the bottom are parallel, you know that these consecutive angles have to add up to 180. So it's going to look like this. Here are some more problems to illustrate that. And that moves us on to circles. And that will be part 3 of our review for your SOL test. Remember, in the next part, we'll do circles and constructions. But after you go through this a couple of times, make sure you turn the sound off and hit pause so you can try to get the answers on your own.